Okay, so in this problem, we want to find the maximum moment. It doesn't say positive or negative. It just says the maximum moment that can be created at B. That's right out here in the middle. Due to this little truck load here. Maybe like a pickup truck. And it's moving. It's on the right side. It's moving to the left. So the first thing we need to do is find our influence line for the moment at B. So remember our strategy before, and will be the same again, is we'll first use Mueller-Breslau principle to get the qualitative shape. So there's my simple supported beam. I'll come to B and I'll imagine a hinge because it doesn't support moment, and then I'll imagine positive moments being applied to both sides, and then I'll use the shape of this structure as my qualitative shape of my influence line. So this point here, under the action of these moments, is it going to go up or down? It's going to go up. So my qualitative shape will look something like this. So now if I draw my influence line, I just need to know the moment at B when the unit load is where? At B. So if I come over here and redraw that structure, it'll look something like this. So there it is. I'm putting my unit load right in the middle at B, and then I'll have a reaction in the Y direction at A and one at B, and this is 100 feet. And I'm trying to also find the moment. I keep saying B, but actually B is in the middle. That's C. Let me correct that right now. So this will be CY. So that means I'm cutting my structure right here at B. Which side do you want to work, right or left? Doesn't seem like it matters. So I'll work the right-hand side. If I work the right-hand side, I need to know AY. And that's not too hard to do. If I sum moments at, did it again, C, what do I get? Should be an equilibrium. So about C, I have my 1, which creates positive moment at a moment arm of 100. Then I have AY creating negative moment at a moment arm of 200. So you solve for AY, you get a half. That shouldn't be very surprising. You have a load right in the middle of a beam, half goes to each side. That seems reasonable. So now if I look at the left side of my structure with my reaction at AY of a half, and I'm trying to find this moment at B, and I'll even include the unit load. Shouldn't create any problems. We'll leave it there. And then this is a length of 100. So again, now if I sum moments at this cut that I just made, which is at C, make sure it's in equilibrium, what do I have? I have my interior moment at B, which is positive. And then I have the reaction creating negative moment of 1/2 times 100. So it looks like my moment at B is minus 50 feet. So that means this is going to be minus 50. I'm sorry, not minus, positive 50 feet. So I'll come back and more clearly draw this. So my influence line for the moment at B looks like this. The unit is in feet, and this will have a value of 50. And of course, that's 100 and 100. So my truck has 2 loads, so how many cases do I have? 2. So here's case 1. One thing you should ask yourself, is there going to be any negative moment created in this beam because of this load at B? No. The whole thing is positive. So let's see if I can draw this. So I'm going to quickly redraw my moment at B. And then I'm going to imagine that my first load comes to that point. So there's my 2 kip force. And then 12 feet back is my 5 kip force. So I'm going to need to find ordinate values at 2 locations. So I already know this value is 50. What's the slope of my line? Well, it's rise 50 over run 100, so it looks like it's a half. So if I go 12 feet, that means I'm going to drop 12 times 1/2 is 6. So 50 minus 6 is 44. So that's my value here, and that's my value there. So that means the moment at B, I'll call it 1 for case 1, is going to be 2 kips times 50 feet plus 5 kips times 44 feet. So what's that going to be equal to? That's 220 and 100, 320? Well, somebody's checking that. I'll draw case 2. Anybody get that value?
Say 320?
I guess 320. So that'd be 320 kip feet. So now I'm going to redraw this again. So my influence line hasn't changed, still the same. But now I'm moving my forces. So now the second force creates the maximum values. There's my 5 kip value. And then 12 feet forward is my 2 kip force. So what are my ordinate values? Well, I know the top is still 50. And these are symmetric. So this is going to be what? 44. Oh, by the way, I forgot. These are all in units of feet. So now my moment at B for case 2 will be 2 kips times 44 feet plus 5 kips times 50 feet. What's that? 3 what? 68? 38. 338. Just a little bit more, but it is. So therefore, the moment at B will be the maximum of those two, or 338 kip feet. And that's when the back axle of the truck is right there. So that's a pretty easy one to get started. Any questions about that? Okay.